Hello and welcome to Chapter 10, Section 5. This is all about experimental probability. This is our introduction to probability. And so we're going to start with a bunch of vocabulary. An experiment is an activity involving chance. A trial is each repetition of an experiment. So if I wanted to know how many times I get heads when I flip a coin 20 times, the experiment is the whole shebang. A trial is each time I flip the coin. The outcome is each possible result of a trial. So for any trial, I could get heads or tails. There are two outcomes. The sample space is the set of all possible outcomes. That would be heads and tails. So the first set of questions are going to ask you to identify the sample space and the outcome. And we have some common things that get asked when we're talking about probability. If I toss two coins, what's our sample space, the set of all possible outcomes? Well, if I toss them and the first one is heads and the second one is heads, that's one of the outcomes. The first one could be heads and the second one could be tails. The first one could be tails and the second one heads. The first one could be tails and the second one could be tails. And that's all that there is possible. So that's our sample space. If we actually flipped two coins, then we would figure out what our outcome would be. Spinning a game spinner. Well, your sample space is I could either get red or green or blue or purple. So that's our sample space. And then if I actually spun the spinner, if, it wasn't drawn on my paper, that would give us the outcome. Rolling a number cube. Now, this is the way they say dice, but they usually don't roll two dice, they roll one, and one dice is called a die, and they don't like saying that, so they call it a number cube. And your answers are 1, 2, 3, 4, 5, or 6. Continuing with the vocabulary, an event is a set of outcomes in an experiment. Probability is how likely an event will occur, and probability happens with numbers. There's also a question that they'll ask you is about the likelihood, and when you estimate the likelihood of something happening, that's when you use words. The words that usually get used are impossible, which means it has a 0%. It absolutely cannot happen. It is unlikely. It's as likely as not, which means it's exactly 50%. And unlikely means anything between these two. And then there's likely and there's certain. It's the only outcome you can have. And then likely is anything in between these two. So questions that ask about likelihood. How likely is it that there will be 31 days in August? Well, there are always 31 days in August, so this is going to be certain. Carlos correctly guesses a number between 1 and 1,000. Most people would say impossible, but truly, it's actually unlikely. It's an extremely small percentage. Carlos just isn't that lucky. So it is unlikely. A coin lands heads up. Well, he's got a 50% shot at that, so that's as likely as not. Alan. Cecilia rolls a 10 on a standard number cube. Well, a standard number cube has the numbers 1 through 6. So it is impossible that Cecilia will roll a 10 with only one cube. Get it? So when we talk about experimental probability, we're talking about a ratio. Here we finally get to the math part. And this is a ratio of the number of times an event occurs over the number of trials total. So if you were to flip a coin, this is the number of times you flip the coin, and this is the number of times it lands on heads, for example. This is not heads versus tails. Probability is heads versus total. It's always versus total if it's probability. So we have a frequency table here. And one of the questions might ask you, what is the experimental probability that a spinner lands on blue? Well, it's the experimental probability because I actually tried it. I have a spinner and I spun it this many times, and 7 times it landed on red and da 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 da. So what is the experimental probability that it lands on blue? That would be the number of times the event occurs, 8, over the number of times total. 7 plus 8 is 15, plus 5 is 20. There are 20 total. And I would reduce this to 2/5. And then the probability that the spinner does not land on green. Well, not green means red and blue, so that's 15 over the total. And I would reduce this. Get it? Now that we're actually doing math, I'm going to ask you to pause here and do check it out number 3. Come back when you're done. Check it out number 3A is the experimental probability that a spinner lands on red, and that is 7 times out of 20, and that a spinner does not land on red, that would be the other 13 times out of 20. And then we have word problems. How do we actually apply this to real life? Well, there was an inspector who came by at the light bulb factory, and he looked at 800 different light bulbs, and he found that 796 of them have no defects. So the first question they ask is, what is the experimental probability of no defects? So when they did it, there were no defects out of this total time, and if in your calculator you put in this division problem, knowing that you're going down, 796 divided by 800, you're going to get the percentage of 99.5%. So there is a 99.5% probability that the light bulb has no defects. Well, then let's apply that. What if we had to predict the number of light bulbs out of 2,400 light bulbs that are likely to have no defects? If I get another shipment of light bulbs and there's 2,400 in there, how many of them are going to be good based on this experimental probability? So I'm going to find 99.5% of 2,400, which means I'm going to turn this into a decimal and I'm going to multiply. And I'm going to see that 2,388 of them will have no defects. Make sense? Pause here, try check it out number 4 so you can play with this a little bit yourself before you have homework. So we have a scenario where we have 1,500 motors and 1,497 of them are found to have no defects. What is the probability of no defects? Well, they've given us the fraction and we just have to find the percentage, and that's 99.8%. And then if we are given another 35,000 motors, how many of them should have no defects based on the experimental probability? So I'm going to multiply 35,000 times 0.998 and I'm going to get 34,930. Okay? That is experimental probability, your introduction to probability. Your homework starts on page 740. We're going to do numbers 12 through 23 all. Please make sure you ask if you have any questions. I will see you tomorrow.